Hello, advanced math concepts students. So today we're going to be taking a look at page 20 of our Unit 2 packet. We're going to be talking about optimization today, which is actually related to a calculus topic. Granted, we will not be doing calculus for today, but it is an introduction to optimization. Okay, so we should all be on page 20. So this is something I just kind of wanted to bring to your attention. If you ever did decide to take calculus in college, you will see maximizing and minimizing problems like this. So you might ask yourself, what are the dimensions of a rectangle with a fixed perimeter, and then gaining a max area for that rectangle? What are the dimensions of a cylinder and given that volume? Okay, so these are just some questions you could be asking yourselves. I know. We ask ourselves different questions in the day, I guess. So also some other things that, this topic relates to. I actually really love teaching this lesson because there are a lot of cool applications to it. It pertains to physics, economics, okay, business, and obviously math. Okay, but the way that we're going to go about tackling these problems, right, because we're not going to be taking on the calculus portion of it. We're not going to be doing any kind of derivatives or integrals, but we are going to be taking a look at solving these optimization problems in a way that we're able to do so. So these are our steps, guys. We want to read the problem. Okay, do you understand it? Do you know what's given to you? Draw a picture. This is going to be really important. Okay, and introduce variables. You're going to want to list the different relationships that these variables have. Okay, so let's begin. Let's take a look at our first example. All right, so we have 500 feet of fence. Okay, we have 500 feet of fence is used to enclose a rectangular plot of land. So I'm going to draw a rectangle because it says rectangular plot of land. And there's an existing wall on one of the sides. So there's a wall on one of the sides. Okay, so there's a wall. I don't know where the wall is, so maybe I'll draw it over here. Okay, maybe there's a wall here. There's a wall on this side. Okay, doesn't matter. I could have also, if I drew my picture, I could have also drawn the wall here. Okay, and blocked this part off. Doesn't matter. All right, so let's just use the blue drawing that I have already. And we want to find the dimensions of the rectangle with a maximum enclosed area. So I have 500 feet of fence that's used to enclose this rectangular plot of land. But look, I have fence here, right? I have fencing here. I have fence here. I don't have fence over here. There's a wall there. So I only have fence on these three sides. That's really important. Okay, so here we have a wall. And I'm going to start to introduce some variables. So maybe I'll call this x and this y. Now if I call this x because it's a rectangle, this also has to be x. Okay. And remember, they told us the amount of fencing. So there's 500 feet of fence. So that's our perimeter. Our perimeter is 500 feet of fence, but it's only for these pieces, right? Our perimeter is only covering here, right? We don't include the wall. Okay, we're not including the wall. Okay, so I also know my perimeter is equal to, well, I have x plus y. So I have 2x plus y. So if both of these things are the perimeter, I'm going to set them equal to each other. I'll have 500 is equal to 2x plus y. All right. We also want to figure out what the max area is. So I've got this equation here. Okay. What's our formula for area of a rectangle, guys? What's our formula for area of a rectangle? Area of a rectangle is length times width. Length times width. So in this situation, I have a length of y, and I have a width of x. So I could have rewritten this, though, as area is x times y, or y times x. Doesn't matter. Okay. I don't know. What do I do? just give up. Don't do the problem. No, we're going to figure it out. Okay, so we already said this. I just want to write this a little neater. So we said that this 500 was equal to 2x plus y. Okay, well, why don't I get one of these variables by itself? Let's get y by itself here. Let's get y by itself. And I have y will equal negative 2x plus 500. Okay, so far so good. All I did was get y by itself. All right, well, our end goal is to find the max area. So I'm probably going to want to use my area formula. So we already have y. We just got it. So let's plug it in. I'll have area is equal to x times negative 2x plus 500. Okay, we can distribute. I'll have area is equal to negative 2x squared plus 500x. Okay, great. I have a formula now for area. I've got a formula now for area. Well, think back, guys. We talked about finding max and mins. Does anyone remember the formula we used to find a max or a minimum? I'll draw a picture. Let's see if this helps. So I drew my picture. My max is up here. And there's a formula that I can use to find what that x value is. Anyone remember? It's the axis of symmetry. If I use x equals negative b over 2a, I will find the maximum x value. Once I find the maximum value for x, we can always plug in to get y. Remember, we talked about that? So this is really the point x, y. If I use this formula, it'll get me x. In the end, if I want y, we'll have to plug it back in to our equation. Okay, but I'm a few steps ahead, so let's just make sure we're okay with this. So axis of symmetry formula we use for maximizing and minimizing things, right? I could have drawn a picture that looked like this. Okay, I could have drawn something that looked like this. We would have a minimum here. Still using the axis of symmetry formula though, if I wanted. Okay. All right, so let's erase this and let's go back to the problem. So this was just some extra info. Okay, well, if this is my formula for area, I'm going to use the axis of symmetry formula. I'm going to use the axis of symmetry formula to figure out what the max value is for x. Once I have x, I can go and plug in and get y. So let's see. We have a is negative 2. We have b is 500. So let's plug into the formula. X equals negative 500. Whoops, no negative there. All over 2 times negative 2. And you guys have calculators. 500 divided by 4. Well, it's really negative 500 over negative 4, which is a positive value of 125. So we just found x to be 125. Now, my picture is obviously not drawn to scale. Okay, or maybe it is. I don't know. So that's 125 feet. Well, I want to know the dimensions of the rectangle. I know x, right? I know x, and I have an equation for y. So I'm going to plug this in. I'm going to get y. I have y equals negative 2 times 125 plus 500. And again, you guys have calculators, although you don't need it here. You get your y value to be 250. So those are my dimensions, 125 feet and 250 feet. So our width, or length, it doesn't matter. Our width is 125 feet, and our length is 250 feet. So these are the dimensions for us to find the maximum enclosed area for this space right here. Okay. All right, let's move on to the next page. Let's take a look at page 21. We're going to look at example 2. And we have a rectangular sheet of metal. It's 10 inches wide. It's going to be made into a gutter. Okay. We're going to turn up the sides of equal length perpendicular to the sheet. and we want to find the length that it must be turned into to produce a gutter with a maximum cross-sectional area. So I'm actually going to kind of redraw this here. So if I were to kind of flatten this, and that's why we have this dotted line here piece, that's actually to help you. So if I have, here is the actual gutter, and if I were to flatten these sides, okay, that would be over here and over here. And we have the entire length is 10 inches if we were to flatten those edges. And I know from here to here is X, from here to here is X. So if I know this whole length is 10, this is X, and this is X, well, we can just take the difference for this area to be X minus 2X. Not area, I'm sorry, length. This length to be X minus 2X. Okay, so we actually have a lot of information now. Okay, so from our picture, right, so I have a few things going on here. And we want to just make sure, let's just go back and read the question. I just want to make sure we know what we're asking for. We want to find the maximum cross-sectional area. Okay, so the maximum cross-sectional area, guys, if I were to draw on this, okay, this is my cross-sectional area that I'm looking for. That's what I'm looking for. So this length, we actually already found. That was this. That's this length. So I know this length here is 10 minus 2x. And we already have this part. This is x, right? It's given to us. I just kind of have it covered up. So let's draw another picture. This is 10 minus 2x. This is x. I want to find the maximum area. Maximum area. Remember the formula I said we use for max area is x equals negative b over 2a. That's our axis of symmetry formula. Well, before we can even use that formula, we need to come up with the area. And area, we said, is length times width. So we're going to multiply these things. We have x times 10 minus 2x. We're going to distribute. I've got area equals 10x minus 2x squared. I'm going to rewrite this in standard form. Okay, we're going to rewrite this in standard form. Now, I have a quadratic equation that I can work with in terms of finding the axis of symmetry. Remember, the axis of symmetry helps us determine max and mins, and in this case, we're finding a max. So we're just going to plug in my a value. So let's write this on the side here. Let's do a different color. We have a is negative 2, so that's here, and b is 10. So I have negative 10 all over 2 times negative 2. And you don't need a calculator for this again, but if you decide to use one, you would get x to equal 2.5. So now I know my value for x, so that's this height here. And again, I'm sorry, I was kind of covering this. Okay, so I know this height of the gutter here, that x value, is 2.5. And the question is asking for the maximum cross-sectional area. Well, I'm just going to erase this so there's not taking up so much space here. But we already found a formula for area. It's right here. That's our formula for the area. Our area is equal to this negative 2x squared plus 10x. So I'm going to plug in my x value of 2.5. So I have the area will equal negative 2 times 2.5 squared plus 10 times 2.5. And we end up getting 12.5. And this is an area, guys, so you just want to make sure you're including units. And we're looking at inches. So this is inches squared. Okay, so that would be my maximum area for this cross-sectional area here. Okay, for the gutter. All right, so we had the x value. Once we had the x value, we plugged back in to our equation. All right, guys, I hope you found this video helpful. We're going to continue with maximizing area tomorrow as well.